Here we have AP calculus AB problem. Okay, let's go the information. Let f of x equals to 2x negative 3 if x less than or equal to 2. F of x equals to x squared positive a if x is greater than 2. Find the value of a so that f of x is continuous at x equals to 2. Okay, so before I start solving this problem, let me list out the conditions for which a function has to be satisfied when it is continuous at a particular value. Let's say that a function f of x is continuous at x equals to k. If your function f of x is continuous at x equals to k, then it has to satisfy three conditions. The first condition is when I plug in this value k for x over here, this f of k has to be defined. That is, f of k is defined. And the second condition is limit x approaches k. Let me write over here. F of k must exist. Let me write it over here. And the third condition is f of k, the value we got in step 1 and the value we got in step 2 must be equal. That is, limit x approaches k, f of x. Okay, so these are the three conditions I have to check whether a function is continuous at x equals to k. So here I don't have to verify all the three conditions for the given function f of x, because already the question says f of x is continuous at x equals to 2. Since the given function f of x is continuous at x equals to 2, the given function will satisfy all the three conditions over here at x equals to 2. Since f of x will satisfy all the three conditions over here at x equals to 2, the function f of x must satisfy this particular condition also at x equals to 2. That is, limit x approaches to f of x exists. Let me write the stuff over here. Okay, here we got it that limit x approaches to f of x exists. Actually, f of x is a piecewise function. Since limit x approaches to f of x exists, that is, the ordinary limit of x approaches to exist, the left side limit of x approaches to f of x and the right side limit of x approaches to f of x must be finite and equal, because the ordinary limit of x approaches to f of x exists. Okay, now let me evaluate the left side limit of x approaches to f of x. Let me write it over here. Limit x approaches to minus f of x. Here I have taken a negative sign on the right side top corner of 2. So it indicates x approaches 2 from its left side. Okay, let me draw a number line over here. Here I have taken 2. So x approaches 2 from its left side. When x approaches 2 from its left side, all the values taken by x will be less than 2. Okay, now we have to consider the piece of f of x where x is less than 2. So this is a piece we have for f of x when x is less than 2. So now what we have to do is we have to plug in this 2x into 3 for the f of x over here. Let me continue. So limit x approaches to negative, and for this f of x we can plug in the first piece at where we have x is less than 2. So that is 2x negative 3. Okay, this negative sign will do nothing with the calculation part. It just indicates that limit x approaches 2 from its left side. Okay, now what we can do is in our next step, we can plug in the limit 2 for x over here. Then I'm getting 2 times 2, negative 3. So which is 4 negative 3 equals to 1. I have evaluated the left side limit of x approaches 2 for the function f of x. Its evaluation is just 1. Okay, now let me evaluate the right side limit of x approaches 2 for the function f of x. That is, this time x approaches 2 from its right side. In that case, the values of x will be greater than 2, because all the values over here are greater than 2. Now let me write the right side limit, that is limit x approaches to positive f of x. So here I have taken positive sign. This positive sign indicates x approaches 2 from its right side. When x approaches 2 from its right side, all the values of x will be greater than 2. Now we have to select the piece for f of x where x is greater than 2. This is a piece we have for f of x at where x is greater than 2. Now I have to plug in this x square positive a for f of x over here. Then I'm getting limit x approaches to positive x square positive a. Now we have to plug in this limit 2 for x over here. Then I'm getting 2 square positive a, which is equal to 4 positive a. Okay, now I got the left side limit of 2 and right side limit of 2 for the function f of x. And both the left side limit and right side limit must be equal, because already we know that the ordinary limit, that is limit x approaches to f of x, exists. Okay, now we have to equate this and solve for a, that is the left side limit 1 and the right side limit 4 positive a. So 4 positive a equals to 1. So to solve for a, I have to get rid of this 4. For that, I have to subtract 4 from both sides. When I do so, this positive 4, negative 4 will cancel. A equals to, when I combine 1 and negative 4, I am getting negative 3. So when the function f of x is continuous at x equals to 2, the value of a is negative 3.